In this lesson, we're going to be discussing the derivatives of trigonometric functions. Now we're going to start with derivative rules. So we have that the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. However, the derivative of tan is 1 over cosine squared of x. Now, the justification for the rules of sine and cosine can in fact be done using the derivative from first principle, which we will be tackling in another lesson. However, the derivative of tan can in fact be justified using the quotient rule of derivatives. So over here, it's because of the fact that tan is in fact written as sine x over cosine x, which in fact is in the form u over v, where u is sine x and v is cosine x. So basically u prime here would actually be cosine x, since the derivative of sine is cosine, and v prime would be negative sine x, since the derivative of cosine is negative sine. Now we know that the derivative of u over v is u prime v minus v prime u over v squared. So which leaves me with the derivative of tan to be. Now u prime times v, this is cosine squared x, minus v prime times u, which is negative sine x, over v squared, which is cosine squared x. Sorry, this is negative sine squared. V prime u is negative sine times sine, so that's negative sine squared. Okay, so at the numerator, we're left with cosine squared plus sine squared, and at the denominator with cosine squared. Now, cosine squared plus sine squared, according to the Pythagorean identity, since we're dealing with the same angle here, is equals to 1, which leaves me with the derivative of tan to be equals to 1 over cosine squared. Now, 1 over cosine squared is also referred to as secant squared x, which we know that secant squared is 1 plus tan squared x, so the derivative of tan could also be given as 1 plus tan squared. Now, if we look here at the chain rule of these corresponding properties, now similarly to when we introduced derivatives, we spoke of the chain rule, which in fact consists of a situation where you're having the function, instead of being given in terms of x, it's written in terms of a function of x. So here u refers to a function of x. For example, instead of having sine x, what if you had a sine of x squared plus 3x plus 1? So sine would in fact be given in terms of a function of x. So in that case, to find the derivative, the same rules would apply. So the derivative of sine u is still cosine u, but we have to multiply by the derivative of the expression inside, which is u prime, according to the chain rule, and similarly to cosine u and tan u. Now let's just move to solving some examples here. So over here, I need to determine the derivatives of each of the following functions. We are given the first function to be cosine x times sine x. Now cosine x times sine x, we can first look at this as u times v. We can look at this as the product of cosine and sine. So over here, u is cosine x, so u prime would be negative sine x, and v is sine x, so v prime would in fact be cosine x. So according to the derivative of a product, u times v has a derivative of u prime v plus v prime u. So f prime of x would in fact be u prime times v, so this is negative sine squared, plus v prime times u plus cosine squared x. So that would in fact be the derivative of f of x. However, we can look at this question using another method. So over here in method 2, we know for a fact, according to the double angle identities of sine and cosine, that over here sine 2x is 2 cosine x sine x. Now, why would I think of the double angle identity of sine? It's because I do have a product of cosine and sine. They have the same angle. So having the same angle, I do have that product in the double angle identity of sine. So cosine x times sine x can also be written as half sine 2x. So over here, writing f of x as half sine 2x would also allow me to differentiate it using the form sine of u. So over here, this is in the form sine u, where u is 2x, so u prime would actually be equals to 2. So finding the derivative. Now, the derivative of sine u is cosine u multiplied by the derivative of the expression inside, which in this case is 2. And we should not forget the half that we had here to begin with, because sine u is sine 2x, so I do have a half here multiplying sine u. So over here it's half times 2 times cosine 2x, and half times 2 is 1, so that is cosine 2x. And we do know that cosine 2x, according to the double angle identity of cosine, is in fact equals to cosine squared minus sine squared. So you'd notice we did end up reaching exactly the same answer. Now, if we were to look at the second function, now f of x here is 1 over cosine x. Now, I would look at this as 1 over u. Whenever you need to find the derivative, it's always important to identify the general form of the function. So here f of x is written in the form 1 over u, and we know that the derivative of 1 over u is negative 1 over u squared. Now, in order to revisit these rules, it's really important to revisit the previous lesson where we introduced derivatives. So over here, u is cosine x, so u prime is negative sine x. So f prime of x would in fact be. So over here, it's in the form 1 over u. So the derivative is negative 1 over u squared. However, if u is the variable of differentiation, in that case, the derivative would be negative 1 over u squared. However, if u is a function of x, according to the chain rule, this should be multiplied by a u prime. So over here, this would in fact be negative u prime over u squared, according to the chain rule. So u prime is negative sine x multiplied by negative, that would give me sine x, divided by u squared, which is cosine squared x. And you could leave this in this form. Now over here in this other example, we have f of x to be x squared sine 2x. Now in the previous example, we had a product of cosine and sine here, and since they had the same angle, we could have avoided the product rule by just using the double angle formula of sine. However, here I'm multiplying x squared by sine 2x. So in this case, there's no way to be able to escape the product. So here we start by considering it in the form u times v, where u is x squared, so u prime is 2x, and v is sine 2x, so v prime is, now the derivative of sine is cosine, and of course it's cosine of the same angle. Now multiplying the derivative of the expression inside the function of x that the function is written in terms of. So over here u is 2x, so we have to multiply by 2 since 2 is the derivative of 2x. So over here f prime of x would be u prime v plus v prime u according to the product rule. So u prime times v, this is 2x sine 2x, plus v prime times u, which is 2x squared cosine 2x. Of course, no further simplification is required here. What matters is to be able to identify the terms and the derivatives of each term in the product and then apply the product rule properly. Now for this other function, we have it as tan x over 2, which is in the form of tan u, where u here is half x. So u prime, now that's linear, so its derivative is the slope of that linear expression, which is half. Now we know that tan of u, now this may not really look like a u, so let me just fix that. Okay, so f prime of x, now the derivative of tan u is 1 over cosine squared u, and of course that is multiplied by u prime according to the chain rule. So f prime of x would actually be half over cosine squared of half u. Now over here, the half, simplifying this, since we have a fraction at the numerator, the denominator of that fraction drops down to the denominator of the entire fraction, so that would be 1 over 2 cosine squared of half u, and that is the derivative of f of x. Now in this third example, we have here f of x to be sine of square root of x. So again, that is in the form sine u, where u is square root of x, so u prime is 1 over 2 square root of x. So f prime of x, the derivative of sine u is cosine u multiplied by u prime. So f prime of x would be 1 over 2 square root of x times cosine of square root of x, which you could also write as cosine square root of x over 2 square root of x. Now in this last function, we have cosine cubed of x. We can actually see this as cosine x all cubed. Now this is not really in the form cosine u. Now in fact over here we have a power with a function of x at its base. So in fact we see this as the form u cubed, where u here is cosine x and u prime is negative sine x, since the derivative of cosine is negative sine. So over here the function of x is not inside of a cosine. Over here we have a power where the function of x is at the base of the power, and then in that case the function of x is cosine x. So that is in the form u cubed. So the derivative here, the derivative of a power is 3u squared. We drop exponent, we subtract 1 from the exponent, so in this case the derivative of u cubed is 3u squared. And chain rule, we do not forget to multiply by the derivative of the expression inside. So over here f prime of x would in fact be replacing each by its expression. Now u prime is negative sine, so that would give me negative 3 sine x times u squared, which is cosine squared of x, and that would be the derivative we are actually looking for. So that is it for the derivatives of trigonometric functions. Now, of course, in the following lesson, we're going to be discussing derivatives of inverse trigonometric functions as well as an extension to this lesson, in addition to tackling the derivative of cotan x as well.